Welcome. Let's wrap up the objects as workplaces feature we're implementing. So just as a quick recap, we're using recipes to tie objects where entities can work and various input items together to get certain output items. And today we're going to work on how the world interacts with this. And we went over this twice before. We'll do it in a bit more detail today. So we already talked about the recipe data type. We made sure that we can resolve craft drops, and today we'll hook it up into the world so the world can spawn jobs that entities can pick up. Now, how will we be doing that? Well, first, we need somewhere to store our recipes. So we should have a place where all the recipes that we know of in this game are. Could be a JSON file, but we will use a hard-coded array that we'll define. Then we need to have a way of transforming relevant recipes into jobs. And relevant recipes are those recipes for which an object exists in the world. And we'll use a new function on the recipe type for this, the createJobsInWorld function that will return an array of jobs. Of course, we'll write some tests to validate that it's working correctly. Once we have that, then we can trigger the creation of jobs in the world. And finally, we'll update our demo world to show the effects of these actions. So let's get started. So let's start Xcode. Basic Builder tutorial project. And first, we'll start by defining the recipes we know. And we will use more or less the same solution we used for items already. We'll create an extension for a recipe. And this will have a variable that returns a specific recipe, in this case, a cook recipe. And this will be a recipe. And this requires an object, some required items, and a resulting item. And let's also add these items and objects as well. So for instance, we need an input item. Let's say we have an item called food. This is sort of the uncooked food. And it can just be called food. And let's assume we also have an item called a cooked meal. And this too will be an item. And we will call this a cooked meal. Then we can define the required items and the resulting items. So the required items will be food. We'll have an item stack, and this will take food, and it only requires one, and it will return a cooked meal. You should have item and an amount, and this it will return one cooked meal. One cooked meal. We also need an object to cook at, so we'll have an extension called for object, and this will have a static variable kitchen counter. This will be an object, and this object will be called kitchen counter. It will have a size, and it will be 3 wide and 1 high. It's basically the same as the one that we're already showing in the game. It will have an install time of 5 ticks, and it will be allowed to be installed on a floor only. So now we can also hook up the object here, the kitchen counter. Now we at least have a recipe to work with. So the next step is to add an option to our recipe type to create jobs in the world. So let's get started. So we will create a new function called create jobs in world, and this will return an array of jobs. And for now, let's simply return an empty array. So we have a sort of stub we can use in testing. And let's see if we can add to this a function as we write the tests that show the required, the intended behavior. So we have our recipe tests, and I'll quickly add a marker here that the first tests are all about single job tests. And we will now have a marker that tests multiple jobs. This way we can quickly see in the outline view navigate to where we're at. So we have a test for creating jobs in the world. And the first test will be a test, create jobs in the world. And this should create craft jobs. So let's get a world. And also let's get a recipe. For this test, we will create our own recipe. And this requires a test object because I don't want this test to be more dependent on anything outside of the system and the test and necessary. This will require an input item, and we require 4, and this will result in output item about 2. And we will make sure that the world has this object in place, so it's a test object. And then the jobs we will get will be recipe.create jobs in this world. And let's start by asserting that after this function, jobs should have at least 1 entry. And then let's check on what kind of job this is. The first job call we will switch on if it's a craft job. Very good. If it's anything else, then we fail the test. Because this job should be a craft job. This test will fail, but at least let's see if we can compile and run it. It's testing, but we actually get an index out of range error because we're returning an empty array. So let's go back to our recipe. Actually, let's make this test a bit more resilient. So let's say let's at least make sure that we have a first job. So that job equal to jobs. But first we can unwrap. This requires throws. We can try and unwrap jobs.first. And if this fails, then we will already get our error, and then we can simply switch on our job call. This at least shouldn't crash the program, but still fail the test. Okay. So let's go back into our recipe and start implementing this function a bit. So let's first get all the relevant positions, and the positions will be where they're in the world object, where there is We don't need this one. We filter. We filter on where the job has the correct name, or the object has the correct name. So our object dot value dot name equals object dot name. So where this object's name matches an entry in the world, and this will get back a filtered list. But this is still a key value pair, so we need to map this to only get the positions back. That's the key. And now it should have an array of positions, array of vectors. Then let's make sure that all the jobs, let's create jobs, and these will be the positions, but we'll map these for position in, and we'll use our create job at position function to transform these positions into jobs. So now we get an array of jobs, and we can return these jobs. And now if we run the test again, the test passes, so we get back a graph job. So that's nice. So let's go a step further. We have our graph job, but there is an issue that we should have. We're only validating a creation of a single job. But if there are multiple objects in the world, we might want to create more jobs. So, for instance, if there are 2 kitchen tables or 2 test objects in this case, then I'd expect 2 jobs to be created, and that's not what we're validating yet. So let's create multiple graph jobs. So again, we have our recipe, we have our object on the right, but this time we also have an object on the left, and this again will be a test object. And we will use the same function, but this time just validate that we get 2 back. Let's run this one. This one should pass immediately. Now, there is a problem with this setup, and that is that depending on how often you try and create jobs, you might get an endless list of graph jobs, because each time it will try and create one. So I think it's a good idea to have a sort of max jobs property for a recipe. That's the maximum amount of jobs of a specific type that a recipe can have in the world. So let's go into a recipe and create an additional property called max jobs. This will be an integer. And this also means that probably a lot of code needs to have a max amount set. So let's just say that our recipe can have max jobs of 1. Make sure we don't get too many. Let's also let's see what else we have. We have a test here, so we should have a max jobs here as well, and here, and here, and here. But we could have a few more here, especially to have the second test work correctly. Let's say we have 2. Let's see if this builds. Maybe we forgot some, but I guess not. Let's try and run all the tests to see if we're missing anything. Okay, the tests are still passing. So now we can create a new test that says test that we don't use more than there are max jobs in the world. So let's create a test, create jobs in a world. Can't create more than max jobs. So again, we need our world, and our recipe. It will have a max jobs 2. And this time we will have yet another test object in place in the world. So we will have 3. There is one at 0 as well. We have the 3 objects that can spawn jobs. Again, let's create the jobs in the world and assert that the jobs.count is still 2. So let's run this one. So if we don't take the max jobs property into account, and this will most likely try and create 3 jobs, but we only want 2, so that's what we're expecting. And that is expected, this test fails. So let's go to our recipe and make sure that in our create jobs in world function, we actually take the amount of jobs, max jobs into account. So one way of doing this is to return the jobs array, but in a slightly different way. Return an array. It takes the jobs from 0 to the minimum of jobs.count or the max jobs value. And because we might have an empty array, let's just make sure that that jobs is more than 1. So let's guard jobs.count is bigger than 0. Otherwise, we will return an empty array. So let's see whether this helps. So let's run the test again. And now the test passes. But there's still an issue here because it doesn't yet take existing jobs into account. So it will try to create 2 new ones at most every tick. And I also want to make sure that we can't create more than max jobs, but we're taking the existing jobs into account. So we have our world. We again have 2 items, but we have some, and we will enqueue these jobs in the world. So let's say for job in jobs, we do world.jobs.enqueue. So then we should have 2 in the world. And then let's say the extra recipe create jobs in the world. And let's assert that these extra jobs are 0. So we don't get any additional ones. Let's run and see the test fail because we're not taking the existing ones into account. So let's go back to recipe, I think one final time, and make sure that we take this into account. So let's try and see if we have a create jobs in the world function. So let's say we have jobs to create as a number. That will be the max jobs minus the existing jobs.count. So we should find the existing jobs of the specific type. And the existing jobs will be world.jobs.filter. And we'll filter on to see if the job goal, if this is a graph job. We'll have an item stack. We'll see if this is this exact same type of job, and we can do this by comparing the item stacks. So if the item equals the resulting item and the amount matches as well, then this is what we return. Otherwise, we always return false. And this should give us a filtered set of jobs that are only jobs of the same type that this recipe creates. Then we can do these jobs to create. Then we may need to make sure that we test whether this one is larger than 0. If it's not, then we simply return the empty array. Then we can do all the jobs. And finally, instead of doing jobs, max jobs, we do jobs to create, because that takes the max jobs into account. So let's go back to our test. The test should now pass. Also, all the other tests should pass as well. And that's it for our recipe. So let's go to our world. And as we said, in our world, we need a way of getting jobs for objects. So let's see. So for instance, let's create a private function here. We will call this one create jobs for objects. And we'll say for recipe in, we need to find a list of all recipes, and we don't have that one yet. What we'll do is we'll create a static variable called all recipes of type an array of recipes, and this will just contain, for now, a cook recipe. So let's go back to our world. So we can do recipe.allRecipes, and for each one of these, we can look through every job. And so the recipes create jobs in world. This is where we use a new function. And then we do jobs.enqueue, and we enqueue this new job. We will call this function from update. So we will say create jobs for objects. And again, we can create a small test to test whether this works correctly. So let's go to our world test and create a new test. It's func test update creates jobs from recipes. And actually, we should have written the test first, of course. Let's see. So we have a world. Let's make sure that we have an object, a kitchen counter at the correct position. Then we will assert that there are no jobs in the world just yet. We call world.update, and then we will assert that this one is now greater than 0. And just to make sure that this world of jobs, just to make sure that this one fails first, let's just first have this thing return. So then we can validate that the test is at least doing what we expect it to test. Of course, this test fails. Let's go back to our world. Get rid of this. Let's get our early return. Run the world test again, and we will see it pass. But that's nice. So we're almost there. So we have tested that we can create jobs from recipes. Let's see if we can also make this somewhat visible. And to do that, what I will do is I'll go into our world, and we have this make demo world function, and let's change it up a bit. So first off, I'll only use one entity. That makes it a bit easier to visualize. Also, a couple of items now have a direct definition. So the wooden block simply has a definition, meaning that we actually don't need this intermediate step. We also have our kitchen counter, so we don't have to make it ourselves directly also. Also, what we should add is some items to pick up. I think it's called wooden blocks. So let's say we have our new world, but items on the left. And this will be an item stack. This will have a food. Let's say we have 10 or so. So we have a create install object job. This is now the kitchen counter, and here as well. Let's see, this one's on the left, so let's put this one down. So we have an entity, we have a job to install, we have some items to use. Perhaps we need to make the update speed a bit slower. So we have our game scene here. This is our update interval. Let's make it half a second, see how that works. And let's see if we can actually see what's happening. So we can see our entity picking up an item and installing the counter. Then it's picking up the food. So it has the foods in store and it's working at the workstation, and it's indeed converting the food into cooked meals until there's no more food to do. So not only were we able to create this recipe system that the objects can act as workstations, and entities can work there and create new items, we're also able to directly visualize that in the game without touching our visualization code. So I think that's pretty neat. And I guess we will see more and more cases where additional functionality doesn't necessarily mean immediately going and changing our your GUI or our visualization system. Okay, so let's go back. So we met this goal. So we have our objects as workstations done. Next time, I want to look at storing items, because basically crafted items now always go into the inventory of the entity that did the crafting. However, at some point in time, you might want to empty your inventory and store the items in the world at a more reasonable place. So that's something that will require a new job type, but it's something next time. So thanks for watching and have a good day.